Right, so in this video I'm going to have a look at the Junior Cert Higher Level Maths Paper 2 2017, and I'm going to have a look at questions 1 and 2. So this is question 1 here. It has these shapes here. You have an original shape or an object shape, and then you've got the image of this shape under various transformations. So you've got image A, B, C and D here. Now we've got to write A, B and C and D into the appropriate places in the table below to show which image comes from which transformation. And we may use each letter only once. So we have axial symmetry, central symmetry, rotation, about the origin and translation. Okay, so let's have a look at the original shape here. We'll do it in order anyway. We'll go to A first of all. Well, that's just simply a translation. We're just taking the original shape and we're just moving it directly up here. So all the sides are parallel. We're not rotating it or flipping it around or anything like that. We're just simply moving it straight up here. So A is just a translation. So A will go in here. Okay, so let's look at B then. Well, B is just axial symmetry in the x-axis. You're just looking at the x-axis like it's a mirror, if you like. So this point is reflected down here, this vertex is reflected down here, this one is reflected directly down here. So it's axial symmetry in the x-axis, so that's going to be B here. So we'll just put B in here, axial symmetry. Now C then is actually a rotation around the origin. So you can imagine if there was something connected to this vertex here and just a rod, if you like, and you just rotated that rod around, this shape would end up rotating around this way and end up here. So it looks like it's rotated anti-clockwise 90 degrees. So this shape is just rotated all the way around here. So C is a rotation about the origin. So C will go in here, and then the other one then must be central symmetry. So it is, this is the origin here, so if you reflect this point in the origin you'll end up here, this point in the origin you'll end up down here, if you reflect this vertex in the origin you'll end up over here, and this one will end up here. So D will go in here, it's central symmetry, so D will go in here. Okay, next one then. Oh yeah, this is just the construction. So what we have to do here is divide the line segment into 3 equal parts without measuring it. Show all of your construction lines clearly. Okay, now I'm going to do this by hand, so you obviously will need to know how to do this using a ruler and a set square and a compass. But the first thing you would need to do is start here and just draw a line up here like this. You then get your compass, put the pointy bit of the compass here, bring your pencil out to here, draw an arc. So I'll do this, I'll do 3 arcs because we want to divide into 3 equal parts. So draw an arc, don't move your compass in or out, put the point of the compass here, draw another arc, and do the same thing again, draw another arc here. So these 3 distances are the same distance from here to here, here to here and here to here. So what you do then is just identify these points as well. So we'll call them C, D and E. Okay, so the next thing we do then is we just connect up. I'm going to connect E to B. So you would just connect E here up to B. Use a ruler obviously. So the next thing you do is you need to draw two parallel lines here and here. They must be parallel to this line here. So you need to get your set square and set it up along here, and a ruler then to slide your set square up and down, and you should end up with one more line like this. Whoops, that's gone off a bit. Start that again. So you should end up with one line like this, another line like this. Again, not too straight, but let me just do that again. So these three lines here have to be parallel. If they're not parallel, then you haven't divided the line segment AB into three equal parts. So you can identify those as well. This point here and this point here, we're on CDE, so we'll call this F and we'll call this G here. So you should find that this and this length here, they will all be the same. Okay, so that's the construction. So next one then is, oh yeah, we have a diagram here. We have a rectangle and we have a shaded region and a non-shaded region here. AB and CD are divided into 5 equal parts. So these distances here are all equal. Now, some of the endpoints of these parts are joined to the line segments as shown. So we've got these lines here. Find the percentage of the area ABCD that is shaded. So we have this area and this area shaded. We got to find out what percentage of the entire rectangle is the shaded region. Show all your workings. So, okay, let's start then. What I'm going to do here is I'm going to use some letters here. I'm going to call this this distance here x. So this distance here is x as well. And each of these individual lengths here I'm going to call y. So this is y, y, and so on. And it's going to be the same on the other side, okay? They're all equal lengths. So what I'm going to do now is I'm going to find the area of the entire rectangle. Then I'm going to find the area of the shaded regions. And then I'm going to get the area of the shaded region as a percentage of the whole, the area of the whole thing. So the area of the rectangle A, B, C, D is going to be length times width. Length times width, isn't it? So length times width is going to be, the length is x, and the width is, well, it's y plus y plus y plus y plus y. It's going to be 5y. So in other words, it's just 5 times xy, 5xy. So the area of the entire region is 5xy. Now let's work out the area of this part of the shaded region here first, and then this one, and add them together. So we'll do the area of the shaded region. The area of the shaded region is, now I'm going to divide this up into rectangles and triangles. So I'm going to divide it up into, this one is a rectangle and a triangle, and this one here also is just going to be a rectangle here and a triangle here. So let's do this one first. Well, this rectangle here is going to be x times y, x times y, or just xy. This area here, it's going to be half the base times the height. Half the base times the height. So that's going to be half. The base here is 2y. And the height here, this distance here, remember, is x. Okay, so all of this here gives me this area here. Let's add this one now. So it's going to be plus, we have another triangle. It's going to be half the base times the height. Well, this distance here is y, so it's going to be half of y times x again. So that's this triangle here. Now we're going to do this triangle here. That's going to be x times y. So all of this added together is the area of the shaded region. So what do we end up with here? Well, we have an xy plus an xy. Well, that's 2xy. We have half of 2, which is 1, so we just end up with an xy here. This bit here is just xy, and here we end up with half xy here. This is just half xy. Well, again, we can add these together. We have 2xy plus 1xy, that's 3xy. 3xy plus half xy is 3.5xy. And I'll just write that as 2, 3, 6, 7 over 2. 7 over 2 xy. This is 3.5 here. Okay, so now I have the area of the shaded region and I have the area of the whole region. So how do you get one number as a percentage of the other number? Well, the first thing you do is find it as a fraction. So I need this as a fraction of this. This is the shaded region over the whole region, and then I'm going to multiply that by 100 to give me a percentage. So the percentage, in other words, shaded region, is going to be equal to the shaded region, which is 7 over 2xy, over the area of the whole rectangle, which is 5xy, and this is the fraction of the shaded region. To turn that into a percentage, we multiply by 100. So it's going to be this percent here, whatever this works out to be. Well, if you look at this, the 7 over 2 is multiplied by the x is multiplied by the y. The 5 is multiplied by the x is multiplied by the y. So we can divide that x by that x and we get 1. We can divide that y by that y and we get 1. So the letters disappear, the x and y's disappear. So we end up with 7 over 2 divided by 5 times 100. So you can do this on your calculator, but we're dividing by 5 over 1 if you like. So how do you divide by a fraction? You flip this upside down and multiply. So it's 7 over 2 multiplied by 1 over 5 multiplied by 100. So that gives us 7 over 10. Multiply two fractions, top by top, bottom by bottom, multiplied by 100. So that 7 over 10 is 0.7 multiplied by 100. So that gives me 70%. So the percentage of the shaded region is 70%. Okay, so that's it for question 2. Questions 1 and 2, in fact.